So today we're going through asynchronous programming in Dart, and this is usually a very I wouldn't say it's hard, but it's a very complicated topic, and that sometimes it's a make or break topic for people doing especially front-end development. If you don't get it so well, it may affect how you're going to maybe receive Flutter or how you're going to develop Flutter apps. Because normally, most things you have to wait for something to happen before. Let's say, for example, in an app, you'll have to wait for the backend to maybe log you in, to give information. So there's a way you can handle this information in a way that will make the experience very good to the user. And if you don't do it correctly, we end up having problems. So asynchronous programming is, sorry. So I don't know how I can turn off this effects, but sorry. So there are quite a number of topics that we need to cover: isolates, event loops, futures, async, await, and streams. I don't know if they're in that order specifically, but I think stream comes before async await. Just a matter of semantics. So first of all, you're going to look at isolates and understand basically just how that works before we go into the asynchronous bit, because understanding these fundamentals will help you understand how your program is running behind the scenes. So it's very important that you understand how Flutter does its work. So Flutter is usually a single-threaded programming language. If you are worked with something like Java, Kotlin, or C, they have like a number of threads. You can like create new threads and basically separate your work between threads, and it's handled faster. But there's also an advantage of having just one thread in a programming language, where handling basically something like garbage collection and making sure that your memory is never corrupted is actually key to that having been a single-threaded programming language. Another language or another framework that is single-threaded is in Node.js. If anyone has used it, this is a very common topic in Node.js. So in that, we have something called an isolate. An isolate basically is whatever, just a space in your machine, or maybe in the case of a mobile app, a state in the mobile device through which that code runs. Basically, it has its own private memory. It has its own like single thread running, though it's possible to create other threads. So an isolate contains of a thread and its own chunk of memory that is not shared between it and other threads for the sake of integrity, so that we don't have another thread affecting the memory of another thread, so that we get corruption of memory. So basically, the word isolate comes from how everything is isolated. However, so when you run your Flutter app, it creates one isolate that it will run your code in. But in case you need to do something that is very intensive, for example, you want to read files and whatnot on the user's device, you may choose to create another isolate that will do that, because you don't want it to affect your main program. Though mostly you may end up working with no other threads, just the single thread that you're working on. So so basically, this is just an example of how an isolate works. So basically, whatever the triangles you see at the top is the memory assigned to that isolate. And down there's a thread, and they're going to cover something called an event loop. So basically, a thread will run one event loop, and the event loop will be assigned, the isolate will be assigned memory where you can put all your data in. So an event loop is a construct in programming where it takes one job at a time and manipulates that job until it's done, and then it goes to the next. Basically, since we only have one thread, we have to kind of form a queue of tasks that we're going to do. So number one, the first task comes in, the purple one. Maybe it's something like fetch HTTP request, or read a file, or do anything that you may want to do. So that is the first task it will do. Then go over, finish it, put it aside, go to the next task. And that is basically how the event loop works in a single isolate. It's very important to understand this because usually, as we will see ahead, this thread may take a very short time, but basically something like fetching something from HTTP will take time. But the advantage is that it will not block the thread. It will just the thread will continue until the data is received. Then it will come back and be processed. So let's just take it as it is right now. We are going to see how it works later on, how it's very, very important. So the next thing we're going to look at is futures. So a future, let's go to the next. Sorry, I think, okay, sorry. I think I misarranged the slide. So a future basically is just a promise that you'll get some value or accomplish a task in the future. So a future will have 3 states. Maybe you have asked for something from the backend or from the HTTP server. It can either be uncompleted, where it has not, we are still waiting for that value. It can complete with a value. Basically, it's successful, so the state is success, not a value. So the state is success, or it can be an error. Maybe, for example, the user doesn't have internet access, so that will yield an error. And if they do have an internet access and everything goes fine, they will get back a value. It's just like when you borrow money from a friend. You may have to wait for it. That is the uncompleted state. You may get the money, or you may get, like, the person may not be able to fulfill the promise. So a future is just a promise that something will happen, or you get a value back at a later time. So let's take an example of this code sample that we have in Flutter. We have a raised button with the text, "Click me." So if you click the button, number one, it will go and fetch the information from the server. And then it will take as much time as it will need. And then later on, it will come and print success if everything was successful. Now let's go back to, so take note of the response, where after we're getting the response, we are checking the status, and if the status is okay, then we print success. Now let's go back to, I think we can go back to the event loop and see how that works. Remember that the event loop, the request may take very long for you to get a response. So let's take that the purple, I don't know if that's a hexagon or something. Yeah. So let's take the example that the purple, we are requesting data from the HTTP. First of all, we will we have that function that will print the status code later on and print success. So what it does is that it will execute that click. Then we will wait for the response, and while waiting, we can process the orange one. So any other tasks that will come while we're waiting for that answer, because we are waiting for that response, because remember that response, our program has nothing to do with that response. That response is fulfilled by another party. So what do we do? Do we wait for it, and does the app hang until that request is found? Or if you click another button, what happens? Is it ignored until that answer comes back? And the answer is no. We will execute any other task that will come through until, now that we told the event loop, when the answer comes back, print success. So let's assume that the blue task is our print statement. statement will come later after you processed other tasks. Let's assume there's even more tasks apart from that, the orange one. So other tasks will be executed until we get that answer, and that answer will execute that function, that function that prints success. So that is how isolates work. If you've ever interacted with a Windows machine, let's say Windows 98, which was prone to hanging a lot, you'd notice that at one point you're clicking. You try to click to open a Word document, for example, or any other program. You click and then you realize nothing has happened. You click and click and click and click. Remember that all those things are being kept in a queue. You will find that maybe after some time, when the system starts responding, it will open as many programs as you clicked. So that is basically how an event loop works. The tasks are just placed in a queue and they're waiting execution. So if there's something that is holding up the queue, these clicks that you did will just hold on and wait in the queue until we are done, and then they will execute at once. That's when you will see multiple programs opening at once. Yeah, so as we said, so you see this http.get returns a future, and a future is just a promise that it will execute. And then when we have the then keyword there, then when the response comes, if the response is okay, print success. So that is basically how it works from a theoretical point of view. So how do you get futures? There are multiple ways of getting a future. For example, we say that our http.get line there returns a future, which we will assign to my future. So most of the time, you'll find that you'll not be creating futures yourself. You'll be calling functions that will return a future. You'll not be creating futures yourself, but there are functions that you can use to get a future yourself. For example, there's future.value. If you know the value that is going to come and you want it to come in future, maybe you may have a function that returns 10, but that is just a normal function that returns 10. How about if you want that 10 to be in the future, so that it doesn't come right now, it comes later on? So basically, that's how it works. We have future.delayed, where you can delay the execution for a given duration, and then the value comes in. Another one is feature.error, which returns basically just an error, and that we will see when you're doing a demo. Then we have feature.wait. Feature.wait will supposed to be feature.wait, not features.wait. So feature.wait will wait for multiple futures. If at all you're fetching things from the server, multiple, and you want all of them to execute and finish. Let's say I want to render a screen of customer and their orders. I may want to fetch to send a request to fetch the customer information and then fetch the orders that belong to that customer. So I may want to wait for those two to come in before I render my screen. So I can wait for multiple responses to come in, wait for them, all of them to resolve, and then continue with what I'm doing. So how do you handle features? We saw in that button example that we have a then function, which executes when the feature completes with a value. Basically, this means that when it's successful, it will run the function that is put under then, because that is the function that will handle successful attempts. We have a catch error function. The catch error function will execute when the feature completes with an error or without an error. That always, oh, sorry. Catch error will execute only when there's an error. Then when complete will be executed whether there's an error or not. Basically, in the end, it will happen. Let's use our example. You've borrowed money and you want to spend that money. Maybe you have a project that you want to spend that money on. So number one, we ask for the money, wait for the response. Someone tells you, I will give you tomorrow. Then if it comes tomorrow, you spend the money or you do whatever you wanted to do with the money, right? And then in the end, if maybe the person may fail to get you the money, then the catch error, let's say the catch error will happen, basically where you will find other solutions, or maybe you will withhold that project that you're working on that needed the money, right? But anyway, life goes on. Whether they give you money or they don't, life goes on. So that is how you can interpret it. So when complete, will execute whether they get the money or you don't. That is how it works. So demo time. Let's do a demo. So let's pause there. Come to our. So I wanted to use a very simple example of where we are. Sorry. Where we are just using the example of getting money and spending money. So basically, we have this feature that you've asked someone for. Let's say, let me hide this unused code. And our screen looks nice. So let's say, for example, you are asking money. You're asking for money from a friend, and then so you ask for 1,000, and then you get. When you get the money, you spend the money, right? When we say then executes when it's successful, right? And then you can see here we have a catch error, which will basically we will be given the error. Maybe they will tell you this is the reason why I couldn't be able to get the money. So you don't spend the money. So basically it has happened. The error has happened, and they can't get the money. But as we say, life goes on. So when complete is life goes on. I want you to take note of something, that we have a print statement down here. And basically, remember that a future we will get the answer back later on, maybe tomorrow. But you have to wait for the money. You'll realize that I have put this statement after all this, the promise and everything. But if I execute, so let's first of all clear that. Clear that. So let's just start from there. So let's try to execute this. Sorry. So you'll realize that waiting for money will come before. The reason why it's done this way is that you see this print statement will be first of all, we will send the get money function to our event loop. Then it will realize that here we have to wait for a value to come later on, right? So we put all these callback functions. Basically, callback function is a function that will execute when something resolves, or when something happens. So our then catch error and when complete are callback functions. So these callback functions will be given to the event loop, and the event loop will be told when that answer comes, execute these statements, depending on whatever happens. Then you see we have our waiting for money here. You see the event loop did not wait for that response before it printed wait for money. You see wait for money is the first statement which we printed on the screen. That is very interesting because your program did not wait for a future that we don't know it will execute at one time. It may take 5 days, it may take 2 days, we don't know that. So what we do is that we just go to the next statement and execute it, which is very interesting. You'll find that very interesting when you're trying to run a Flutter app, where you've clicked somewhere, and while the user is waiting for the response, they decide to click some other button. You also have to handle that button if this feature has not been resolved yet. So we said we can use feature.value that will give us a value later on. So another one we can use is let's get rid of this, comment it out. So we can also use what if an error happens. So let's say, for example, your friend comes tomorrow and tells you, hey, the money you asked for, I don't have it. So what do we do? Let's try to execute this statement on C. Sorry, I think that. So yeah. So you see here where our friend returned with the message that I don't have the money. So I got no money. That's what the friend told us, and that's what we printed here. So the money didn't come, so we didn't spend the money. We don't. You see that the spend money function did not run because the future did not resolve with a value. In fact, instead it resolved with an error, and the error is that I got no money. So that's what happened. And then life goes on, because whether the future was successful or not, we print life goes on. So that is complete. This is something that we may use, maybe for example, I can't think of a good example right now. Maybe, for example, you've requested from data from the server and it has failed, and you still, even if it fails, I want to like go to another screen altogether, whether it's successful or not, right? Yeah. So that is one example. A feature can return an error. Another example is that a feature can we can create a feature out of a delayed statement. Basically, we can wait for, let's say, a duration of 3 seconds, then we get the money. Or wait for the duration of 2 days, then we get the money. See, like that is the part where we're waiting. So if we know the specific time it will take, then we will be surprised that after those exact moment has passed, then it will resolve. So let's try that out. You'll see it will take a bit of time. Let's just try it out. Waiting for money, 1, 2, 3, then get the money, spend the money, life goes on. So that is a delayed future. So another one example that we have is that maybe you've asked 2 friends to give you money, and you have to wait for you to spend the money. You have to wait for you have to wait for the other friend to give you 500, the other friend to give you 500, and basically spend it once. So let's try that. I don't know if there's an error there. So basically what you've got is that you're waiting for the money, you've gotten the money from the 2 friends, and now you have all the money. So you have like 500 for another 500, and life goes on. So that is basically it. You're waiting for multiple future. So this is future.wait, which will take multiple futures. This is future of like value 1 and value 2. And then if both of them are successful, then it'll go on. So this one, maybe this value may be delayed. Let's say, for example, let's just take the example of this. Let's say one of them delays, but you have to wait for those. You need 1,000, right? And one of them delays, and you are getting 500 from one and 500 from the other. So for you to spend the money, you have to wait for both. This one will give you money immediately, for example, and this one will delay you for 3 seconds. Let's just try that out. So you'll see again, waiting for money, 1, 2, 3. So you got the first one, you're waiting for the second one until it's resolved, and then you spend the money, right? So that's as simple as that. So let's go back to our slides. So that is all about features. Though we will, as we go on, we'll be using them, and we will be explaining how and why we are using this kind of why we are using this feature and how it happens. All you need to understand is that a feature will have 3 steps. It can be either uncompleted, it can be successful with a value, and it can have an error. And also, you need to understand how to handle the feature. What happens when it comes? What happens when there's an error? What happens when it completes? Do you want to have something run as when it completes? When complete and catch are optional, you can put them there or not. But remember that if you don't put like a catch error and an error happens, then how will the program? Maybe the program will crash there. So that's why you need a catch error to basically handle gracefully whatever will happen. Maybe it will not be successful, or it will. So next, let's look at streams. So that is the third topic under asynchronous programming in that. So streams are very interesting. Let's say, for example, you are looking at, if you've ever seen any real-time data, let's say stock market, where the prices of a stock are either rising or falling, or for those of us who watch football, you may be watching football through maybe a live app. Let's say, for example, you're watching it on gold.com, or you're watching it on, which other app is there? LiveScore. So you see, when you're watching, some event may happen during the course of the match, and those events keep coming over and over again, and like basically until the match is over, you'll still be getting new events. Let's say, for example, it's commentating, so new events will be coming through. There's a red card, there's a yellow card, there's a goal, there's a penalty, there's a foul. All this information coming through until when all the information, when the football match ends. So that's a very good example. Another example, as I said, is the stock market or Bitcoin value. You'll see that they may display a graph with either going up or down depending on how it goes, or on how the value of the stock is performing. So a stream is just a source of asynchronous events delivered sequentially. So you remember the example we used where someone is clicking multiple times on a button. Basically, another stream is basically clicking on screen, or basically moving your mouse on a screen. The computer will be getting multiple events telling them the mouse has moved here, it has moved here, it has moved here. And if you want, you can always like respond to each move as you want. Maybe we've gone over the start button, like maybe there's a context menu to be shown there, or there's a hint. I've moved elsewhere, then we need to handle that event. That is another example of a stream. So a stream is just used to get a synchronous sequence of data from something like an API, or maybe, for example, if you are reading from a file usually is read asynchronously. If you want to read a file synchronously, that means that the whole thing will block until that function that thing happens. So once all the elements have been emitted, a special event will be called. Basically, that will just notify that we don't have any other value coming through. So that will be the end of it. In the example of our football app, then when the match ends, there's no more information coming in because the match has ended, right? So there's no more yellow cards, no more commentating, no more anything. That's the end of the event. So that is how it happens. So there are two types of streams. Basically, there's a single subscription streams, and all the streams when you create in Flutter and Dart, they are usually single subscription stream, unless you add another function that will make them a broadcast stream. So a single subscription stream will only work with one person listening to it. So for example, the example here, I don't know of a good example, but let's say the clicks on your computer, they're just going to be handled once in your computer. Not anyone else is going to handle those clicks or those mouse movements in your own computer. Only your computer will handle that. So there's only one listener to that mouse movement in that single program. But broadcast streams are used, maybe, for example, let's take an example of our footballing app or our stock app again, where streams are coming in, but they are going to, let's say 100 people have opened that same game or that same stock graph, and it's a broadcast stream because it's going to everyone, multiple listeners at a time. So basically the events are being listened at a time. So there's one thing that you need to know, that without subscribing or listening to a stream, it's just an object with potential values. Basically, it doesn't have anything. Unless you start subscribing to it, then a stream is usually just useless object in a program until someone starts listening to it. So that's how streams work. Otherwise, they will just be spending a lot of computer resources without any tangible outcome. So so let's do a demo, see how streams work. For now, I will gloss over some things, but let's just there are things that I will have to explain maybe later on when we come. Sorry. Let's comment this out. And then we come to our streams. Let's go over this. Let's say, for example, we have a function which when we give it a number, it will give us like 0, 1, 2 until that number. So you'll realize that this is a function that does not have a return statement. Instead, it has yield. Yield is just like this is a value. You'll get another one later on. Basically, it doesn't. You see, normal functions have a return statement where like one function, but what yield does is that it gives you provisional values until when the that's the end of the function. Until that special it comes, then there's no end to it. Let's say, for example, mouse movements. There's as long mouse movements. So that will not have a complete, because you will always be moving your mouse, you'll always be typing something, you'll always be. But for the example of our function here, that basically if we give it 10, it will give us values, and that will have a complete function that will be executed when it's complete. So let's see the outcome. Sorry. So listen to that streams. You remember that streams are listened to. Basically, to someone talk, they will continue coming with new information until that conversation is over, right? So listen. That is basically that. As long as you continue listening. So basically, the complete is not has not been fired yet. We will still continue getting the value. And then let's take an example of. So if we go to our listen method, which I've forgotten how. You see, also when it comes to streams, there's always there's errors can always. Is that for you to handle errors in there's a special on error function that will handle. The callback will have an error. Maybe we just print that error, but in our case, maybe it will not occur because we just like the comp works. We will continue getting a value, or we can basically just induce an error here. So let's say if we let's say if we can throw a new exception, just throw an object, and let's try that out. I haven't tested it out. Let's see. Or we can print basically the error. Sorry about that. Oh, good. So that's that. So basically, remember when 9 comes, we get an error 9. So this is basically how to handle the error. Sorry, this is a stream. Done that way. So basically it has run and there's been an error, and then we say that the stream is complete. So that is basically how streams work. But streams are very and they are very powerful, especially when it comes to, we'll come to a point in Flutter where let's get rid of this error of ours. So let's take the example that I want to only take numbers which are, okay, let's use the example first of, I want to manipulate the numbers that come in and multiply them by 2. Let's say, for example, what is a good example? Let's just say, for the sake of argument, we don't want the numbers that come in, we want those numbers times 2. Because everything comes in doubles. Let's say, for example, I'm dealing with shoes, and these shoes come in 2. So, like, if I get one pair, then that means that that are 2 shoes. Basically, just multiply by 2. So I can put a map. A map basically will just manipulate the value and give the rest. After manipulating that value, it will just map it to a new value, and then you will get that value. So, for example, if we execute ours right now, we see instead of us getting 1, 2, 3, we are getting 0, 2, 4. Basically, just multiplying everything we get by 2. As simple as that. Sometimes you may need to only to manipulate data before it comes in. Some other time, maybe you may want, I only want the numbers that are divisible by 2. I don't care about the other information. Let's say, for example, in a stock, maybe in a stock app, maybe I just want to I only care about the rises and not the falls. Or maybe in a football app, you want to only listen to goals and you don't care about these red cards and yellow cards and fouls and whatnot. So I will just, hello, can I be heard? Ivy? Anyone?
Yes, I can hear you.
Okay, sorry about that. I don't know what happened. I think I got muted for some reason, so I don't know where we were. So basically, you may maybe in the course of that subscription to that specific stream, you may want to cancel, or maybe you may want to basically stop listening to that event. So there's an object called a subscription, which you can use here. So basically, I can do a subscription dot cancel if I want to. Sorry, if I want to cancel that subscription and I don't want to listen to that game anymore, I can just call subscription cancel. I can pause it for some time. I can call pause, I think. So there's a function called pause where I can pause so getting a handle on the subscription is very important. Basically, where we can be able to basically have a better control of that subscription. So basically, that is all I would want to cover about streams for now. Let's go to the next. I think in the next, let's say, 5 minutes, it should be done. Let's just go 10. So the final thing I want us to discuss is async and await. You remember that in our previous examples, let's come back to it. And first of all, mute this. Example. And then you see in our functions here, we were basically handling So basically, we were handling this in a sequential way. But the problem is that, let's say, for example, you remember that we say that you can listen to, basically within one stream, you can listen to another stream. Let's just take an example of let's do this. Let's say after spending our money, we decide to ask for more. So let's just print here. Maybe that's a good example. So basically, we're spending the value. Then after spending the value, after spending the money, we obviously have nothing. So we'll be like, we can return. We can chain as many thens as possible, because we can basically manipulate the value as we go, just the same way we were doing with streams. We can always chain another then do something with that value. So our remaining cache is the next one that comes after that. We can always chain this as we go. But you see, this code of ours doesn't look so nice because we are chaining a lot, and for someone to understand exactly, sorry, I don't know what happened there. So return 0. Oh, it's supposed to print, sorry. So you can imagine, like, it has taken a bit of time for you to spend the money. Now it's turning 0. So you can basically chain as many thens as you can, because let's take a very good example of let's just create a hypothetical function here. So let's take the example of, I have a function where I want to fetch a client's information from the server. For example, I have an e-commerce app. I want to fetch the client, then fetch their order, depending on the client that I've fetched. So for example, I have get client, then I give it, like, let's say X, the client X, dot then, now that this example is hypothetical, we may have to, I don't have autocomplete. So let's say, for example, we have client information. Then from that client information, we want the client ID, so that we can go to the table of orders and fetch orders that belong to this client. So we'll get the client dot, let's say client ID, the client ID, then chain another, then here, then do we have a client ID here, returned from the previous 10 statement. Then we have, like, fetch orders for that client. You see, this doesn't scale so well, and so for someone to come and understand this code, if we are chaining thens, doesn't make a lot of sense. So there's an easier way of going about this, where we can, instead of Sorry about that. I don't want to lose everything there. So instead of us training a lot of thens here to fetch information, then from that information fetch another information, it may not look so nice, especially if you have a very big app. For example, if you're developing a very good clone of Jumia, it will, like, if you have to fetch information from these orders, now I want to fetch the order items, or the basically whichever things that we want to fetch, it doesn't look so nice. That's why we have another basically just syntactic sugar called async await. We will see how it's used. Basically, async await are just keywords in Dart that are, they're just syntactic sugar to make it easy to use streams and futures. We've used it somewhere, but I don't know if you paid attention. We will come back and explain it. So basically, it's just an alternative syntax for handling futures and streams instead of using it, like basically instead of using then and catch error and so on. So instead, your code will end up looking asynchronous. If you've done something like PHP, where I need to fetch information from the server, and then from maybe my database server, you see your code will pause, or it will be stopped until you get that result, then go on. There's a way we can make our code look like that without actually doing that, because we don't want our app to hang at one point. So let's just do a demo of that, then we'll be good to go. So here we have it. Comment that out. Let's take this example of ours. Not okay, not okay. So let's take this example of ours. First of all you need to do is come to your function that you want to be asynchronous, and you put async at the start of the function. This just tells our function that we will be waiting for results to come in before we go ahead. Here you remember that this statement saying where we were printing waiting for money will execute before this part executes. But here we want to basically just wait for it before we go on. If I execute this, you'll notice that since await is just waiting for the response, you'll realize that putting the statements in this order means that I will spend the money, then I will wait for money. You see, it makes it easy for someone to understand. So in this case, we'll put this line here, waiting for money, then we will await. In this example, instead of like going to do other things, this function will wait for the answer or for the money to come in before we go and spend the money. So that is basically it. It makes it very easy for someone to understand your code. Async await. That's why I'm calling it syntactic sugar. It's just a change of syntax, but not really. The functionality behind the scenes is just the same. But here, instead of chaining a lot of thens, we can await for the response and then continue. I will continue as if this line comes after this. So here it will not break. If I do this without an await, like basically this money will just be a future. It will not be a double. It will not be basically, it will not be a double. It will just be, if you see here, it will be a future because I have not awaited. But if I await, then I come here, it's a double because I've waited for the response, for basically the future to resolve, and then after it has resolved, then I get the value. Take note of this function of ours here, get money. What it does is that it returns a future of double. Basically, a future is just a promise, as we said, of whatever kind you're waiting. For us, we are waiting for money, which is basically just a double figure. So if we await that future to resolve, we will get now the double. That is how easy it is. So if you don't await, then if I do this and execute this, because I've not awaited, you'll see like spend money instant of future double. And if I await, instead of working with the future, I'm working with the actual value that I'm getting. So I'm acting with the actual value that I'm getting, and that our function executes very well, and we are spending the money. So you'll ask yourself, now, how about errors? How do I handle errors? Now let's take a very good example of, let's comment this out and get one that has an error. So this is our feature that basically returned an error. Let's see how that will work. You will realize that basically we have an unhandled exception. But here it's very easy for us to do. We just do a try catch. So we will try here. A try catch basically is just a statement. It's just a construct that will help us handle any errors, any eventualities that we're not very sure about, and just catch those errors and basically handle them gracefully again. So here we'll just say, just print, let's say an error occurred. Then we can just, for the sake of it, print the error that has occurred in it. So let's execute it. It will now handle gracefully. It will not exit with an error. So let's try it out to make sure that it's working. Let's not just say. So here we'll just say an error occurred and it exited successfully without any errors. So this is how you handle. And if you have many, let's take our example of fetching client information, then fetching their orders, then fetching their order items. For that example, we will just I can comment this out for the time being. Here we can it will just be as simple as, let's say, final customer is equal to we'll await. If we have a function to fetch the customer information, we'll just await fetch customer. That. Then the next example, maybe we want to fetch the customer orders. Let's assume it's one order. Then we give it the customer ID because we want to fetch for that specific customer ID. And then later on, we want to maybe fetch the order items. Oh, yeah, it's not fetch customer, it's fetch order. And then here it's, let's say, fetch order items. Okay, this is customer order. I hope you understand what I'm doing here, where basically for me to get the items that are in my cart or in my order, I want to know first, give me the customer information, right? Then I fetch the customer information, the one using my app currently. Then number two, fetch the order of that client. Then it will go to the backend because I can't fetch an order without the customer information. Then I get the customer ID from the customer information and basically fetch the order for that customer. And then since the order items depend on the order itself, I await for that customer order to resolve, and then I go to the next. I go to fetch now the orders. In our example above here, we'd have to change so many. So I deleted the code. Sorry. So in that example, we'd have to like this then like someone understanding that code becomes very hard, but this one becomes very easy. And then we can just do a try catch again, as we said. So in case any of those that we've listed there, in case any of the functions fail, then you can just handle the failure once, and then that will be the end of it. So I think that is the end of my demonstration and my tutorial on async await. Maybe other things I may recommend that you go do research on is when it comes to streams, there's something called a generator function. We've used it somewhere, but basically just need to understand it further. Because of time, I was not able to include it in my tutorial. So go look at basically how streams is something that it may have needed its own class, but during because of the short duration of time we have, I decided let's just handle asynchronous programming once. But we have a basic understanding of streams. Now we can go look at generator functions, sinks, and stream controllers. Basically, those are things that you can just go look into them. And if you have any questions, that is your assignment. I think that is all from me today. Thank you. Ivy?
Okay.
So in case you have any problems testing this out, I will again share the code. Ivy, I think, will give me time to prepare the code samples, and then I will share them. If you have any issues, feel free to think about with them. And if you have any issues, you can basically just hit me up on Twitter, or you can ask if there's anyone. I think I saw Candy here. So basically, we have our Flutter Kenya group. Feel free to ask there. People are very resourceful there, and they will help you in case you have any questions. I think most of you are in the group, the on Telegram group. Just ask there or hit me up.
We also have our Flutter Friday WhatsApp. So
yeah, sure.
If you have any question or need the links for the recordings and the GitHub repo, I've shared the WhatsApp chat link in the chat section. Okay, Danvik, Wavinya says the session was amazing and very informative.
Thank you, Esther.
Okay.
Yeah, I'm glad I got some.
Okay. Since there are no more questions, I think we can call it a day. Before maybe we leave, Danvik, what's the topic for the next session?
Sorry, I didn't do preparation mapema. Let me just check. So our next in our roadmap is basically we'll now be getting into Flutter. We'll be understanding user interfaces. Basically, I think this may just come as one. Okay, let's just start with widgets first. Understand widgets. So our next topic will be widgets, but in this roadmap we'll be combining some topics. If we see that some topics are smaller than others, we can just combine them. But in the next, we're going to look at widgets, basically understand how widgets work. There's different there's different types of widgets, the stateful and setlet, and then we'll go on from there.
Okay. Okay.
Yeah. So what you're doing is that by the end of this, you should be able to develop a very professional app. And you see in our roadmap, we have everything. We have basically how to deploy your app, how to do quality assurance, set management, basically just from A to Z of using Flutter.
Okay.
So that's that.
Okay, thank you, Danvik. I think our next session is 9th April. That's in 2 weeks. So I hope you guys continue learning and see you during the next session. Thank you.
Okay, thank you.